IoT Internet of Thing for RGPV Exam 2023 notes are in comment section. Define sensor. A sensor is a device that detects and measures physical or chemical phenomena and converts it into an electrical signal. The signal is then transmitted to a processing unit or a controller for analysis, storage, and further action. Basic components of a sensor node include 1. Sensor. The sensor itself is the primary component of a sensor node. 1. It can be a temperature sensor, humidity sensor, motion sensor, light sensor, or any other type of sensor that is capable of measuring the desired physical or chemical parameter. 2. Transducer. The transducer is a component that converts the physical or chemical parameter detected by the sensor into an electrical signal. 3. Power source. The power source is necessary to provide energy to the sensor node. 3. The energy can be provided through batteries, solar panels, or energy harvesting techniques. 4. Processing unit. The processing unit processes the electrical signal received from the transducer and performs data analysis, storage, and further action. 5. Communication module. The communication module enables the sensor node to transmit data to a central server or other sensor nodes. Challenges faced by a sensor node include 1. Power consumption. Sensor nodes often operate in remote or inaccessible locations, making it difficult to provide a reliable power source. 1. Low power consumption is crucial to extending the lifespan of the sensor node. 2. Data transmission. Sensor nodes may be required to transmit data over long distances or through obstacles. 2. Reliable data transmission can be a challenge in such situations. 3. Environmental conditions. Sensor nodes may be exposed to harsh environmental conditions, such as extreme temperatures, humidity, or corrosive materials, which can affect their performance and reliability. 4. Security. Sensor nodes may be vulnerable to security threats, such as data interception or tampering. 4. Adequate security measures must be put in place to protect the sensor node and its data. Sensor features. 1. Sensitivity. The sensitivity of a sensor is a measure of how well it can detect small changes in the physical or chemical parameter being measured. 2. Accuracy. Accuracy is the degree of closeness between the measured value and the true value. 2. It indicates the reliability of a sensor in providing accurate readings. 3. Precision. Precision is the degree of consistency in measurements taken by a sensor. 3. A highly precise sensor produces measurements with low variability. 4. Range. The range of a sensor is the minimum and maximum values of the physical or chemical parameter that it can detect. 5. Response time. Response time is the time taken by a sensor to detect and transmit a signal after a change in the physical or chemical parameter being measured. 6. Linearity. Linearity is the ability of a sensor to produce a response that is directly proportional to the changes in the physical or chemical parameter being measured. 7. Noise. Noise is the unwanted signals that may interfere with the signal produced by the sensor, leading to inaccurate measurements. Sensor resolution. Sensor resolution refers to the smallest change in the physical or chemical parameter that a sensor can detect and measure. It is usually expressed in units of the measured parameter. For example, if a temperature sensor has a resolution of 0.1 degrees Celsius, it means that it can detect and measure changes in temperature as small as 0.1 degrees Celsius. If the temperature changes by less than 0.1 degrees Celsius, the sensor may not be able to detect the change. Sensor classes. 1. Analog sensors. Analog sensors provide continuous output signals that vary in response to changes in the physical or chemical parameter being measured. 1. Examples include temperature, pressure, and light sensors. 2. Digital sensors. Digital sensors provide discrete output signals that are represented in binary code. 2. They are commonly used in computer and communication systems. 3. Scalar sensors. Scalar sensors measure physical or chemical parameters that have only magnitude, such as temperature or pressure. 4. Vector sensors. Vector sensors measure physical or chemical parameters that have both magnitude and direction, such as velocity or force. Sensor types. 1. Temperature sensors measure the temperature of the environment. 2. Pressure sensors measure the pressure of a fluid or gas. 3. Accelerometers measure the acceleration of an object. 4. Gyroscopes measure the rate of rotation of an object. 5. Proximity sensors detect the presence or absence of an object without physical contact. 6. Humidity sensors measure the amount of moisture in the air. Bias. Bias is an error in sensor measurements that occurs when the sensor output is consistently offset from the true value of the measured parameter. Bias can be caused by factors such as sensor design, manufacturing, or calibration. Drift. Drift is an error in sensor measurements that occurs when the sensor output changes over time, even when the measured parameter remains constant. Drift can be caused by factors such as aging, temperature changes, or mechanical stress. Hysteresis error. Hysteresis error is an error in sensor measurements that occurs when the measured parameter follows a different path during increasing and decreasing values. This can be caused by factors such as material properties, stress, and temperature changes. Quantization error. Quantization error is an error in digital sensors that occurs when the analog signal from the sensor is converted into a digital signal with a limited number of bits. This can result in rounding errors that affect the accuracy and precision of the measurement.